And of course, we also have a theorem which is called the product rule for differentiation. And according to the product rule, if f and g are differentiable at the point x, then the product of these two functions is also differentiable at the point x. And now that the product is differentiable, then the derivative of this product will be given by the derivative of the first function, and we multiply this by the second function unchanged, and then we say plus. We take the first function unchanged, and we multiply it by the derivative of the second function. Okay? Now the question is, how can we prove this product rule for differentiation? Well, firstly, of course, we have to assume that f and g are both differentiable at the point x. And if this is the case, then this is what you will say. You'd say, okay, fine. The derivative of a product of these two functions. And once again, we are going to use the definition of the derivative in order to prove this theorem, okay? So we say, well, according to derivatives from first principles, we have the limit as h approaches 0, but it's the limit of f times g of x plus h, and then we say minus f times g, and then we say of x. But of course, we understand that this entire thing is further divided by h, okay? And remember, for every statement that you make when you are writing a proof, you have to justify, right? Give a reason for that. So here you'll tell them that you actually used the definition of the derivative. Okay, fine. Then the question is, what is the next step? Well, the next step is to define the product of two functions. How do we define a product of two functions? Well, we know that if we have f times g of x, this is actually defined as the product of these two functions. So this is what I actually mean when I say we have to define the product of those two functions, which means for the first one, we are actually going to have f of x plus h, and this is multiplied by g of x, and then you say plus h. Then we go to the second one. Well, here we have f of x, and this is multiplied by an innocent g of x. But of course, we understand that this entire thing is divided by h. And then, of course, here we tell them that we used the definition of the product of functions. Okay, well, that's fine. Then where to from this point? Well, now we realize that we actually hit a dead end at a speed of 180 kilometers per second. Imagine, you would be dead with that speed. But nevertheless, now what do I mean when I say we hit a dead end? Well, if you look at your numerator, there's not much you can do to it, right? And even if you were to look at the entire quotient, you can try to separate the two fractions and say, this one will have a denominator of that, as well as that one, it has a right to claim the denominator of h. But the question is, where is it going to get you? Well, of course, you know the answer. That is nowhere. So then the question is, how do you unhit the dead end in this case? Well, remember, whatever it is that you're going to do, what are you hoping to achieve? The definition of the derivative. Somewhere in the expression, we must have the definition of the derivative. So the question is, what can we do to this expression in order to end up having the definition of the derivative? Well, in this case, we are going to go to the numerator and we add 0 to our numerator. Now, the whole point of adding 0 is so that we don't change the nature of this expression. So now the question is, how do we define our 0? Well, let's keep what we have exactly as it is. And let's go and define the 0 that we are now talking about. Well, this is how we define it, okay? So we are going to add the term. Maybe we can use a different color for that. So we are actually going to add a term here, which is f of x multiplied by g of x plus h. But of course, if we add it, we have to subtract it as well for the reason that I just mentioned, right? And then we say, well, this entire thing is just going to be divided by a solid h. So this is what you say. Now, when you justify this step, you'll tell them that you add and subtract the term f of x times g of x plus h. Okay. Now we move. So what are we going to do next here? Well, remember, our aim is to achieve the definition of the derivative, okay? So what we are going to do here is just to group these terms so that we have the form of that definition. But the question is, how should we group our terms here? Well, if you can look at this part, you can see that if you were to group it with this one, then what is going to happen? Well, grouping alone will not be enough. You'll have to do something extra, which is to take out g of x plus h as the highest common factor. And if you do that, what is left inside of the bracket is just going to be f of x plus h minus f of x. And of course, the same holds for these ones. So even here, you'll have to group them and you'll have to factorize. Okay, well, that's fine. So let's go ahead and do exactly as we say. So looking at the green ones, we can just go ahead and say, well, we have g of x plus h as the highest common factor. And if we take it out, we are left with f of x plus h minus f of x. Okay. Then we close our bracket. Then we focus on which ones? The blue ones. Looking at the blue ones, we can see that f of x is the highest common factor. So if we take f of x out, then we are simply left with g of x plus h, and then we say minus g of x. All right. And then, of course, everything is divided by h. But I'm just going to give both of these terms the denominator of h, right? Because we know what we are hoping to achieve, the definition of the derivative. And of course, if we do that, we need to remember that the entire thing must be in a big bracket. Then how do you justify this step? Well, you'll tell them that it is factorizing and grouping. You did factorize and you group the terms as well. So yes, that is your reason for that. Okay. Now the question is, what is going to happen from this point? Well, here you can see that you are dealing with the limit of a sum of two functions. I think this time I put it at a rather ugly place. So let's put it here so that we can see that we are dealing with the limit of the sum of two functions. And according to the limit laws, we know that it's going to be the sum of the limits of these two functions. But now we also know that we can apply as many limit laws as possible on the same step, right? But then of course we'll have to state all those reasons that we have to specify. We have to tell them which rules for limits did we use. In addition to the sum rule, we can actually see that g of x plus h is a function in its own right. So it means we have this function further multiplied by this function. And the same is true for this one. F of x is a function, and this entire one is a function as well. So it means in just a single step, I'm going to apply two limit laws. Okay? Now this is what I'm going to say. I say it's the limit as h approaches 0 of g of x plus h multiplied by the limit as h approaches 0, but it's the limit of f of x plus h minus f of x. And then I say this entire thing is just going to be divided by h. Then I say plus. I have the limit as h approaches 0 of f of x, and this is multiplied by the limit as h approaches 0 of g of x plus h minus g of x. And we say, of course, this is divided by h. Then the question is, what is the answer, or rather, the reason for this step? Well, here you have to tell them the order in which you apply the limit laws. So firstly, it was the sum rule for limits. Then you say comma. Then you'll say the product rule for limits as well. Okay? And please write it in full. So yes, that's what you'll say. Now we can come back and focus on the first part. So if we look at this one, we can see that, well, remember we said that G is differentiable. And if G is differentiable, then it means G is continuous. So we can simply let H to be 0 there. So we simply have G of X, all right? Then we multiply this by what? We have achieved what we wanted to achieve. The definition of the derivative. Do you see that? So now we can come and say, when we see this one, we actually see f prime of a. And then here, what is happening here? Well, here we can see that we have f of a, and we also have h approaching 0. So h is a variable because h keeps on changing. It's getting smaller and smaller. And f of x is a constant because it doesn't have the variable h in it. So here we can say the limit of a constant is a constant. And of course, that one, you can now see that it's the definition of the derivative. Yes. Of course, the official reason for this step, you'll say it's the definition of the derivative. That's how you justify it. So this implies that the derivative of a product of two functions, if you were to rearrange, right, it's just going to be f prime of a multiplied by g of a, and then you say plus f of x multiplied by G prime of A. And if you said that, they're going to be so happy that they give you all the marks.